Okay, everybody, here we are at lesson 1, area of parallelograms. This is our first chapter with geometry. We're on page 661 and we're in chapter 9. It's all about area. So learning objective A says, I can find the area of parallelograms and use the formula to find missing dimensions. So that's the two parts to this. This is all about finding the area of parallelograms, and this is about how do you find a missing dimension. So if you know what the area is and you know what the base is, how do you find the height? So let's get started with this vocab startup, and let's review what a polygon, a parallelogram, and a rhombus are. It says a polygon is a closed figure formed by 3 or more straight lines. A parallelogram is a quadrilateral with opposite sides parallel and opposite sides the same length. And a rhombus is a parallelogram with 4 equal sides. Fill in the lines in the diagram with polygon, parallelogram, or rhombus and draw an example of each. So what we want to do here is we want to fill out this outer circle with the shape that could have like all 3 be considered like part of that definition. Here's what I mean. A polygon is the most general. It just has to be a closed figure with 3 or more straight lines. So technically a parallelogram is a polygon because a parallelogram has 4 straight lines, and it says it has to have 3 or more straight lines, and it's a closed figure. And so is a rhombus. A rhombus has 4 straight lines, and it's a closed figure. So this big outer circle that contains everything, that's where we would put polygon. So a polygon has to have 3 or more straight lines. So it might be like a triangle, or like look at this. Let's draw something that has 4 sides, but like that. That's not a rhombus and it's not a parallelogram because it doesn't have parallel sides on both. Like these 2 are parallel, but these 2 aren't. So then there's a parallelogram and a rhombus. Now the parallelogram and the rhombus are the same in terms of they both have 4 equal sides and the opposite sides are parallel. However, the rhombus has the 4 sides are all equal length, and the parallelogram is just opposite sides have the same length. So the rhombus is the most unique. That one would go here because the rhombus has to have all 4 sides equal length. So it's kind of hard to draw it perfect, but it's kind of like, well, a square. All 4 sides are equal length and they're parallel to each other. But a parallelogram could be, these are parallelograms, but a parallelogram doesn't have to have all 4 sides of equal length. So you could have something that looks more like a slanted rectangle, or just a straight up rectangle. So it has opposite sides are parallel and opposite sides are equal length. Now, all of these are polygons, all of these are parallelograms, and this is just the most unique. It's the rhombus. And we're going to skip this real world link today and move right into the lesson. So, area of a parallelogram. We've talked about this a little bit already. The area A of a parallelogram is the product of its base B and its height H. So product is the answer to a multiplication problem. So I know that we're going to be multiplying the base times the height. So right here, the base and the height are what get multiplied together, and the formula that we use for area of a parallelogram is area equals base times height. A equals BH. The area of a parallelogram is related to the area of a rectangle, as we discovered in the previous inquiry lab. So we've already talked about how a parallelogram like this one, it's kind of like a slanted rectangle, and that's why it has the same formula to find area. Although when we talked about rectangles, we usually talk about length and width, so length times width, but we're just calling it base and height. The base of a parallelogram can be any one of its sides. The height is the perpendicular distance from the base to the opposite side. So that's why they always show this little right angle here. So you can see that it's perpendicular. This line and this line are perpendicular lines because there's a right angle where they meet. Parallelograms include special quadrilaterals such as rectangles, squares, and rhombi. That's what we were talking about here. Everything in this this medium-sized circle is considered a parallelogram. So rectangles, the slanted rectangle, square, and the slanted square, they're all parallelograms. All right, so let's get some practice. Actually, before we get some practice with this, I want to talk about the units. So everybody write units right here. So units are like, if the base is inches and the height is inches, then what's the unit going to be when you do inches times inches? So it says the area of an area measurement can be written using abbreviations and an exponent of 2. For example, if it's just units times units, then it's units to the power of 2, or units squared, or square units. If it's inches times inches, then it's square inches. If it's feet times feet, square feet. And if it's meters times meters, it's square meters. Or if it's centimeters times centimeters, it's square centimeters. And the reason why the units are squared is because you're doing units times units. And when you're multiplying the same units, then that's when you can use the exponent. Remember, when all the factors are the same, you can write a power with a base and an exponent. So that's why we'll do one more. If you have inches times inches, when all the factors are the same, we write a power with a base and an exponent. So that's why our units are square units for area. All right, so let's do this. Area equals base times height. The base here is 6 units. So if you count across 1, 2, 3, 4, 5, 6, let's label that. And the height is 8 units. So you have to find that perpendicular line again, because we can't measure across here with our little squares. We have to go from here. 1, 2, 3, 4, 5, 6, 7, 8. And area is base times height, so 6 times 8. And we mentally know that 6 times 8 is 48. So the area is 48 square units, or 48 units squared. You can write it just like that. Let's get into our little practice. Here's a parallelogram. Then we're going to practice on these two. So one more example. Now this is different because on our last one, that perpendicular line was inside of the parallelogram. But here, it's drawn outside. It's still the same thing. It could have been drawn in here the same way. 11 centimeters. It's just showing you that it's out here. Remember how this little triangle, if you cut it off, it could go in there? And that's why a parallelogram is like a rectangle. They have the same area. So find the area of a parallelogram. This is the little estimate. Like this is about 20. This is about 10. So it's going to be around 200 square centimeters. Area equals base times height. The base is 20. The height is 11. Do you guys see how they threw in this 13 here to maybe confuse you? When we're talking about height, we're not talking about the slanted measurement. We're talking about the perpendicular measurement right here. So it's the 11 and the 20 that we care about. So 20 times 11 is 220, which is similar to what was estimated. So the area is 220 square centimeters, or 220 centimeters squared. All right, now let's go into the examples. We have to count the square units in this one. So let's find the base. The base is 1, 2, 3, 4, 5, 6 units. And then the height, let's come up here, 1, 2, 3. So then the area is going to be 6 times 3. And we all know 6 times 3 is 18. So if this is units and this is units, then this is going to be square units for our units. Sounds weird when you say units so much. So the answer to that is the area equals 18 square units. All right, let's take a look at this one. This one's kind of skinny. Like, you can't just draw it straight in here and have it stay in, the height can't stay inside of the parallelogram. So we know that the base is 4 meters. And what's the height? The slanted one is 17. The perpendicular one is 16. We always want the perpendicular one. So that's just trying to trick us right there. So our area is going to be 16 times 4, or 4 times 16. Let's talk about that. Multiplication follows the commutative property, right? So it could go either way, base times height or height times base. You're going to get the same answer. If you do 16 times 4, 6 times 4 is 24. 4 times 1 plus 2 is 6. So your area is 64, and it was meters times meters, so 64 square meters. That would be our area. All right, now, just a reminder, you can use a calculator in Chapter 9. I'm letting it happen. So I'm going to get my calculator out. All right, setting this here. Got my handy dandy calculator box. We might want to use it. All right, here we go. So we have the second part of this lesson is to find the missing dimension. So this is getting back into our how do we solve equations in Chapter 7. How do we solve equations? We're going to need to know that for this. It says a formula is an equation that shows a relationship among certain quantities. To find missing dimensions, use the formula for area of a parallelogram. Replace the variables with the known measurements, then solve the equation for the remaining variable. So this is going to be the key here. And to solve the equation, remember we need to use inverse operations. And we need to follow the property of equality. So what we do to one side of an equation, we have to do to the other side to keep both sides equal. All right, find the missing dimension of the parallelogram. So we have a base of 45 the area, sorry. The area is 45 square inches, and then the base is 9 inches. Now we know that area equals base times height. So 45 inches equals 9 inches times the height. So what we did here was we used the formula, we replaced the variables with the known measurements. We know A and B. So if we have 45 equals 9 times h, to get the h height, we can use the inverse operation of multiplication and divide each side by 9. That's going to cancel these out and get h by itself. So 45 divided by 9 is 5. That means this height right here is 5 inches. And you can check your work. So to check your work, plug in our base 9 and our height 5. 9 times 5 equals 45. It worked. So let's try this one. We know the area and we know the height. So we know area equals base times height. Let's plug in the numbers we know. 48 equals, let's see, we don't know the base. We do know the height. So how do we get base by itself? What are we going to do to both sides? The inverse of multiplication is division. So divide this by 6. Those will cancel out. We'll get base. Divide this by 6. So what's 48 divided by 6? It's 8. So the base is 8 meters. So let's put that over here with the units, and let's just check and make sure. 6 times 8 is 48. All right, so far we've been able to solve these without a calculator. All this mental math, it's great. All right, what do we have here? So we know the height is 8 yards, and we know the area. So area equals base times height. Area is 96. Base we don't know. Height is 8. So how do we solve this equation to get base by itself? We need to do the inverse operation to cancel out this 8. Divide both sides by 8. Now I know what 96 divided by 8 is. Do you? Think about this. You could go like this, but that doesn't really help. I guess it does. 1 right there, and then 2 right there. Or you could just mentally know that 8 times 12 is 98. Or you could use the calculator. 96 divided by 8 is 12. So we're talking yards here, 12 yards. And if you check your work, let me see, it would be 12 times 8. Does that equal 96? Yes, if you know your 12s mentally. Or there it is. Okay, so there should be one more practice on the next page before the guided practice. So let's do one more together. And I want to read this first. Height of parallelograms. For the parallelogram formed by the area shaded black in example 4. So see this parallelogram right here. Its height, 12 inches, is labeled outside the parallelogram. So that's just like what we did. Where was that one? Right here. Where it's really thin and you have to show that perpendicular line outside of the shape. So let's look here. Ramilla is painting a replica of the national flag of Trinidad and Tobago for a research project. Find the area of the black stripe. So the black stripe is shaped like a parallelogram. We use area equals base times height. So our base is 6 3/4 inches. There you go, plugging it in. The height is 12 inches. And now we have to do 6 3/4 times 12. And I can think of a few ways to do that. The way they did it was they changed 6 3/4 to a fraction. So 27/4 times 12, that would look like this. 27/4 times 12 over 1. Remember that? And then you just multiply across. Or actually, you should simplify before you multiply, because 12 can be divided by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So 27 times 3, and then 1 times 1. Now, if you use your calculator, or you can do 27 times 3, it's 81, which is what they got. Now, if you plugged this into your calculator, you'd have to know that 3/4 as a decimal is 0.75. So if you used a calculator, it would be like 6.75 times 12. So 6.75 times 12 is 81. So you still get the same answer. All right, now you're going to need to partner up for the guided practice. In the guided practice, we're doing 1 through 5. Here's what I want you to do. I want you to do number 1, then watch it. Do number 2, then watch it. Do 3, then watch it. 4, then watch it. 5, then watch it. So you can go one at a time on this side, and then be ready to go independently for the independent practice. All right, this is just like examples 1 and 2. So if you need to look back at these examples, do it. Okay, do number 1. So when I do number 1, I would say the base is 1, 2, 3, 4, 5, 6. The height is 2. So area would be 6 times 2, which is 12. And we're talking about just general units here. So the answer would be 12 square units. All right, do number 2. So same thing, area is going to be base times height. So area will be 10 times 5. And 10 times 5 is 50, and we're talking about feet, so it's square feet. So 50 square feet. Do number 3. Okay, they're trying to trick us here. We don't need this slanted measurement. We just need base and height with the perpendicular measurement. So area is going to be 11 times 7, and we know that's 77, and we're talking about meters here. So 77 square meters is going to be the answer there. All right, now this is like example 3 right here, where you have to use the inverse operation to find the missing dimension. So start by writing out the formula, remember? Then plug in your numbers. All right, go. Find the height of a parallelogram if its base is 35 centimeters and its area is 700 square centimeters. So its area is 700, the base is 35 times the height. So to get height on its own, we can cancel out or undo this multiplication by dividing both sides by 35. And that 700 divided by 35 is going to leave us with h. So you could do this in long division style, or you can use your calculator. I'm going to use the calculator here. 700 divided by 35 is 20. And then that should be 20 times 35 would be 700. So that works. And we're talking about centimeters here. So the height is 20 centimeters. All right, now let's look at number 5. The size of the parallelogram piece in a set of tangrams is shown to the right. Find the area. Okay, so we just need to find the area. So this is example 4 up here. Figure out what 2 dimensions are the important ones, base and height. And go ahead and solve it. So I don't need this one. I need the base and then this perpendicular height right here. So area is going to be 2.6 times 5.1. And I could do that if I wanted to write it out and do the multiplication myself, or I could use my handy dandy calculator. And that gives me 13.26. And if I think about it, this is about 3 times 5. 3 times 5 would be about 15. And this is a little less than 3, so that makes sense. And we're talking centimeters. So I'm going to put the units square centimeters. All right, and that's the guided practice. You should be ready to go for the independent practice on your own. Okay, so on your own, you're doing the independent practice. And just like examples 1 and 2, or over here 1, 2, and 3, you're going to do 1, 2, and 3. And then 4 is like example 3, where you had to find the missing dimension. And then we're going to do 5, which is like example 4. And I believe, yeah, we're using this picture right here. So it's just like with the flag, but we're using this car. So go ahead and do 1 through 5 and then check your work. All right, to just go over these, we have 3 units times 3 units equals 9 units, which, by the way, to show your work for this, you just need to show plugging the numbers into the formula. So just show area equals 3 times 3, and that equals 9. So for this one, area equals 6 times 4, and that is 24, and it's millimeters, so square millimeters. And here to show your work, area equals 8 times 9, or 9 times 8. which equals 72, and we're talking about centimeters, so it's square centimeters. For here, you have area equals base times height, so 24 equals base times 3. Undo the 3 with division on both sides. So, why did I put area here? So it's not the area, it was the base. Base equals 8 feet. So 24 divided by 3 is 8. And then to check it, 8 times 3 equals 24. Now, for number 5, area equals 9 1/4 times 18. So if you do this out with the fractions, you turn 9 1/4 into an improper fraction. 37/4 times 18 over 1. That's an improper fraction too. I simplified before I multiplied. 333 halves is 166.5 square feet. If you plug it into the calculator, you would turn 9 1/4 is the same as 9.25. 9.25 times 18 is 166.5, which is 166.5. So you could write it either way, and we're talking about feet, so square feet is the units. Time for the reflection. So the reflection for lesson 1, you're going to have to find the area of a parallelogram and use the formula to find missing dimensions. So first, to find the area of a parallelogram, we have to do what? We have to multiply what? So use words. If area is A, base is B, and H is H, what is the formula for area of a parallelogram? Write that out here, A, B, and H. Then label base and height on this parallelogram here. Here, find the area of the parallelograms below. Show the formula. So you have to do what I did here, where you show area equals the base times the height. So show the formula when you show your work. You can use a calculator and remember the units. All right, then number 2, if you know the area and the base of a parallelogram, you find the height by what? What do you have to do? Use words. If you know the area and the height of the parallelogram, you find the base by what? So these are like basically the same answer. And then on the back, find the missing dimensions. So show your calculations and use a calculator if you want. Remember to put in the units. The area of a parallelogram is 27 square centimeters. The base is 3 centimeters. So show your work to find the height. And here, this is the area, this is the height. Show your work to find the base.